Now that we've spent some time getting to know endpoint devices, let's connect the dots. Because here's the big question: what do these devices actually depend on in order to work on a network? A laptop, smartphone, printer, IP phone, server, or IoT device does not do much by itself if it cannot connect, communicate, and reach the services it needs. So, this lesson is all about the relationship between endpoint devices and the network itself. We're going to tie everything back to three big ideas: communication, connectivity, services. Endpoint devices are useful only when the network helps them reach what they need. That is why the CCST blueprint treats endpoint devices as a core topic, and why students need to connect endpoint understanding to applications, protocols, connectivity, and host networking. A beginner mistake is to think that if a device turns on, it is ready to work on a network. But power is only part of the story. A device may boot up just fine and still not able to do what the user wants. For example, a laptop can turn on, but if it cannot reach Wi Fi, the local network, the default gateway, or the internet, then web browsing, email, cloud apps, and video meetings may all fail. A printer can power on, but if no one can reach it across the network, then it is not very useful as a shared resource. A phone can look connected, but if it cannot reach call control services or the wider IP network, the call will not work. So, the real idea is this: endpoint devices do useful work only when the network is available and functioning. At a beginner level, most endpoint devices follow the same basic pattern. They connect to a network, get network settings, send requests, receive responses, and use network services. That pattern shows up again and again. A browser on a laptop sends a request to a website. A phone connects to a service. A tablet streams video. A printer receives a print job. A smart thermostat sends status information. A server responds to requests from other devices. Different device, different purpose, same basic networking idea. They all depend on the network to carry information from one place to another. Before an endpoint device can communicate, it has to connect. That connection may happen through wired Ethernet, Wi Fi, cellular, or in some cases, another specialized wireless method. The CCST blueprint specifically expects students to understand the difference between wired, Wi Fi, and cellular technologies. So, whether the endpoint is a desktop, laptop, smartphone, printer, or smart device, the first step is the same: it needs a path onto the network. If that path is broken, weak, misconfigured, or missing, the device may still be powered on, but it will not be able to do its network job. Once the device connects, it usually needs network settings so it knows how to communicate properly. That often includes things like an IP address, subnet information, a default gateway, and often DNS server information. Hosts can receive addresses manually or through protocols like DHCP, and the default gateway is what helps devices reach remote networks. In plain English, that means the device needs to know: who am I on this network? Who is nearby? Where do I send traffic that is not local? How do I find services by name? Without those basics, the endpoint device may be physically connected, but it still may not communicate correctly. A really important beginner idea is the difference between local and remote communication. Sometimes an endpoint device is trying to reach something nearby. For example, a laptop printing to a local network printer, a phone reaching a local Wi Fi router, a computer talking to a file server on the same local network. Other times, the device is trying to reach something farther away. For example, a website on the internet, a cloud storage platform, an online email system, a video meeting service. That is where the default gateway becomes important. The blueprint specifically includes the default gateway under routing concepts. So, a good beginner way to say it is if the destination is local, the device may communicate directly on the local network. If the destination is remote, the device usually needs the router or default gateway to help it get there. Endpoint devices also depend on protocols. Protocols are the rules that let devices communicate in a structured way. The blueprint includes common network protocols like DHCP, DNS, HTTP, HTTPS, ICMP, NTP, and others. You do not need to explain every protocol deeply in this lesson, but students should understand the big picture. DHCP helps a device get network settings. DNS helps turn names into IP addresses. HTTP, HTTPS help web browsers reach websites and web apps. ICMP helps with testing and error reporting. NTP helps devices keep accurate time. So, endpoint devices are not just plugged in, they are constantly relying on network protocols behind the scenes. This leads us to a really important point. The network is not just carrying traffic, it is helping endpoint devices reach services. That is what makes the network useful. A few examples: a laptop reaches a web service, a phone reaches voice or messaging services, a computer reaches DNS and DHCP services, a printer receives print services, a server provides files, apps, or authentication. An IoT device may reach a controller, gateway, or cloud platform. So, students need to be able to discuss how networks support services like web access, file transfer, DNS, and time synchronization, not just raw connectivity. So, when students think about endpoint devices, they should think beyond the device itself. They should also ask, what service is this device trying to reach, provide, or depend on? Not all endpoint devices depend on the network in exactly the same way. A laptop may need broad access to websites, cloud platforms, email, file sharing, video meetings. A smartphone may move between Wi Fi and cellular while still trying to reach the same kinds of services. A printer may mainly need to receive print jobs from local users or print servers. An IP phone depends on the IP network for voice communication. A server may depend on the network to receive requests and return services or data. An IoT device may need only one narrow job, like reporting temperature, detecting motion, or receiving commands. So they do not all use the network the same way, but they all still depend on it. This is where networking becomes practical. If the network has a problem, the endpoint device is often where the problem shows up. For example, no IP address may mean the device cannot join the network correctly. Bad DNS may mean a website name will not resolve. Poor Wi Fi may make a video meeting unstable. No route to a remote service may stop cloud access. High delay or loss may hurt voice or video. A gateway problem may prevent access outside the local network. That is why the blueprint also includes basic diagnostic tools like ping, traceroute, and NSLookup. Those tools help answer practical questions like, can the device reach something? Where does communication stop? Is the name resolution working? So endpoint devices and troubleshooting go hand in hand. Let's make this practical. Imagine someone opens a laptop at home. They connect to a Wi Fi, their device gets network settings, they open a browser, they type a website name. DNS helps translate that name. Their traffic is sent through the local router toward the internet. The remote service responds. The laptop displays the page. Now think about how many things had to work for that one simple action. The endpoint had to connect. The device needed correct settings. The gateway had to work. DNS had to work. The network path had to work. The remote service had to respond. That is what it means when we say endpoint devices depend on the network. This matters for your CCST studies because endpoint devices are not a memorization only topic. Yes, the blueprint expects you to recognize endpoint categories under Objective 3.3, but to really understand those devices, you also need to connect them to connectivity, protocols, local and remote communication, services, and troubleshooting. That is what turns a vocabulary lesson into networking understanding. In real life, support technicians do not just identify a laptop or printer. They ask questions like, is it connected? Does it have an address? Can it reach local resources? Can it reach remote services? Is DNS working? Is the gateway working? That is the practical mindset this lesson helps build. So let's wrap this up. Endpoint devices depend on the network because the network gives them the ability to connect, communicate, reach services, send requests, receive responses, and do useful work. A laptop depends on the network for web access, email, and cloud apps. A phone depends on the network for communication services. A printer depends on the network to receive jobs. A server depends on the network to provide services to other devices. An IoT device depends on the network to report, monitor, control, or automate. So, the easiest way to remember this lesson is endpoint devices are where people and systems use the network, but the network is what makes those devices truly useful. And that is the big picture. No connection, no communication. No communication, no services. No services, much less value from the endpoint.